guys. So sorry I couldn't be there today, but we are going to continue with our new lesson, so that's exciting. So we're actually starting a new chapter. Sorry, I'm trying to set myself up here as I'm talking to you. And it's a lot of it you're like semi-familiar with, so that's good. We're going to do a lot with radicals, like breaking down radicals, which we've done before. So that's nice. We have a little background info. So in this chapter, we are going to be talking about complex numbers. So today you're just going to kind of follow along, maybe take some notes. You are going to be trying some problems in a problem set. So you'll start that and then we'll just continue next week with some more notes and try some more problems. So that will be that. So a complex number is set up in the form a plus bi. And you're probably saying like, what the heck is that? Now the I is the thing that makes it complex. So I is called an imaginary number. We need imaginary numbers when we need to take the square root of a negative number. Sorry, I'm just trying to write things as I'm saying them as well. Need to take the square root of a negative. So as of right now, if you had the square root of a negative somewhere, you would just say like, oh, no solution, can't do it. But we have this whole other number system out there that you guys have never even heard of. And those are the imaginary numbers. So a complex number is made up of a real part and an imaginary part. So we're going to be talking about that imaginary part today. Like, what the heck do we do if we see a negative? And we'll go from there. So basically, the main thing that we need to know is whenever we see the square root of a negative, so I'm just going to say the square root of -1 is just the most basic, we are going to replace that with an I. So I kind of try to curl my eyes so it doesn't look like a 1. I like put an aggressive dot there. But anytime you see the square root of a negative, in this case it's -1, so you could say 1i if you wanted to. But anytime that square root of a negative is going to be replaced with an I. So let's just look at some super basic examples. If I said the square root of 4, you would say that's 2. Okay, we're starting off real hard here. But if I said the square root of -4, in the past you'd be like, I can't do that. Yes, you can. That would be 2i. Okay, so basically the negative becomes the I, and then you just take the square root of the number like you normally would. So the square root of 4 is 2, but the square root of -4 is 2i. So if I said the square root of 49, you would say a 7. Hello. If I said the square root of -49, you would say, oh, well, the square root of 49 is 7, but that negative is there, so that's 7i. Okay? So really not that big of a difference from what we're normally doing. It's just when you see that negative, you put an I with it. So if I said the square root of 24, remember you do have to break down your radicals if possible. Square root of 24 is 4 times 6, depending on how you did in the past. I always do it with perfect squares, so that would give me 2 square root of 6. So if I said the square root of -24, you would say 2i square root of 6. Okay. So that's kind of the main idea of today. So when we see negatives under square roots, to be able to simplify them, we use that I. So there's just some other little ones. So let's just try one or two quick, just before we get into some more stuff here. So just quickly, you try these on your own. What is the square root of -81? What is the negative square root of 18? And what's the square root of -10? So I'm just going to give you a few seconds. You can always pause it if you need more time. So the square root of -81 shouldn't be bad. You're thinking, oh, there's going to be an I, and I know the square root of 81 is 9, so the answer to this is 9i. I threw this one in just to see if you're paying attention. You only put an I if the negative is under the square root. I can do that. You could have done this before. The square root of 18, you can break it down to 9 and 2, is 3 square root of 2. That negative just stays out there. There should not be an I in that answer. So just as a heads up, you only have an I when the negative is under the square root. So I just wanted to throw that one in there, be a little fancy. And then this one, you're probably saying, well, I can't simplify the square root of 10. But that negative means we would write my answer as I square root of 10. All right, so that's the main idea, and kind of we're going to be building off of that with our eyes here. So we're going to look at some other stuff. That stuff will be kind of built in as we go, and we'll try a few more problems. So I mentioned before, we're talking about complex numbers. They have the form a plus bi. So a is the real part, like just the regular number, and then bi is the imaginary part because there's an I with it. So we're going to start combining imaginary numbers. And I'm just going to make a quick note to myself when I'm combining imaginary numbers, I'm really just combining like terms. So if I have an imaginary, I can only combine it with an imaginary. If I have a real part, I can only combine it with a real part. So just like a little addition and subtraction. So some examples. So first example, if I had 12i plus 6i, you would say, okay, I'm just going to combine them, right? Because they're both imaginary parts. 12i plus 6i is exactly what you think it's going to be. It's going to be 18i. Just like combining x's or y's or whatever. So if I said negative 11i minus 7i, you would say, okay, just combining again. Since they're both imaginary, I can combine them. Negative 11 minus 7 would give me negative 18i. Okay. So what if I said 8i plus the square root of negative 25? So when we're looking at it, we're like, those don't really look like they're like terms. But if you ever see a radical here with a negative underneath, we can just make that an imaginary number, right? So we can rewrite this as 8i plus, I know that I'm going to have an I in my answer because of the negative there, and we know that the square root of 25 is 5. So we can rewrite that as 5i, and now we see they are like terms, and that will come out to 13i. So just like you would with x's or y's or a's or anything, i's are like terms. So you can add them, you can subtract them. So we can also do things, in this case, sometimes they have I, sometimes they're written as the radical, and you would kind of rewrite it. That's fine as well. So if I said the square root of negative 36 plus the square root of negative 100, you would say, okay, right now, but let's rewrite them. The square root of negative 36, when I simplify it, is 6i. The square root of negative 100 is 10i. That one can combine to 16i. Beauteous. So let's try this one. Sorry, I'm getting a little messy with my work here. If we have 2 times the square root of negative 16 minus 3, the square root of negative 64. Sorry, I'm just going to kind of separate my problems here. There we go. We have some simplifying to do. So as I'm simplifying this, I know that the square root of negative 16 is 4i, but we do have that 2 there, so that actually ends up being 8i. Over here, we have minus 3, and we know that the square root of negative 64 would be 8i. So that would turn into minus 24i. So once again, you kind of simplify your radical. If there's a number out there, you just multiply by it. But then our main goal is to subtract these. 8i minus 24i is negative 16i. Beautiful. Let's try one more. Let's look at this one. Okay. So we don't have perfect squares here, which is fine. Life happens. So I'm just trying to simplify what I can. What I notice is I know I'm going to have an I here, but square root of 6 I can't break down. There's no perfect squares, nothing really happening. But I can rewrite this. I'm going to rewrite this so 2 is going to stay where it is. I'm going to put an I outside to take care of that negative, and then I have square root of 6. So you really, in a final answer, you never want an I under the radical. So you take care of it by taking that I out. Excuse me, a negative. I don't even know what I just said. You never want a negative under the square root. This one, I have the 3. I know I'm going to have an I that I'm going to take out, but 24 I can break down, right? 4 times 6. So I'm just going to rewrite it 3 times. That would be 2i square root of 6. So I'm just going to rewrite it because that would end up being 6i square root of 6. Okay, just as a reminder of radicals, because it's probably been a while since you've like combined them with addition and subtraction. I feel like we break them down a lot. When you're adding or subtracting radicals, it's kind of the same idea. They have to be like terms. So to combine something with square root of 6, it has to have square root of 6. So we can combine these. So I would just combine their kind of coefficients in front. 2i plus 6i would give me 8i square root of 6. So remember that doesn't change. So that's that. So a few examples of just combining things. Main goal is we are combining like terms. So if you have i's, you can combine them. If you see radicals, I just switch it so it's in that simplified I form so that I can combine them. And then when you get here, you're just doing your best to simplify your radicals and see what you can do. The main goal is when you see a negative under a radical, you put that I on the outside. So that's the main takeaway from today. All right, let me give you one or two to try just to it's always nice to kind of be like, all right, what the heck's happening? Can I do it on my own? So I'm going to give you 10i minus the square root of negative 121. And then why don't you try this one? 2 the square root of negative 18 plus 3 square root of negative 27. So I'm just going to leave this up for a few seconds. You can always pause it if you need an extra minute to do them. And then I'll start to go over them in a second. So I'm going to start. Once again, if you need, you're probably going to need more time. So just give me a little pausey. So I'm starting this, and I'm sorry, my hand's always in the way. I have 10i. I'm going to simplify that radical, right? So I'm going to write it as 10i minus. I know the square root of 121 is 11, and I see a negative, so I'm going to write that as 11i. Then I can combine them, and that would just be negative 1i, or you could just write negative I. Perfectly fine answer, but that's as much as you can combine. Over here, we have a little more simplifying, right? So these are not perfect squares. We have to break them down. We have to do all that fun stuff. So I just focus on the radical. Square root of 18. I know there's going to be an I there with it as well. What's that give me? 9 times 2, and the square root of 9 is 3. So that would give me 3i square root of 2. So just make sure that you don't forget about the I. And then don't forget that there was a 2 on the outside there. So I'm just going to bring that down. Let's break down this bad boy. So that's what, 9 times 3? So that would give me, since the negative is there, 3i square root of 3. Bring this 3 down. So that gives me 6i square root of 2 plus 9i square root of 3. Okay. And as I'm looking at this, I'm like, wait a second. We said we could only combine like terms. We said we could only combine things that had the same radical, and these do not. So if you ever see this happen, you're done. Since this is a square root of 2 and this is a square root of 3, those are not alike. They cannot be added or subtracted. So you just kind of keep them as two separate terms. So just as a heads up, if that does pop up, I wanted you to see it. But you have a little simplifying. So that's a little bit of practice for those. So there's just one more thing I wanted to do with you. So the last thing, we're going to start multiplying. So we add, subtract, we multiply, divide, all the fun stuff that we can do with any number. There is some little special things that happen when multiplying. So let me show you those first, and then we'll just try a few examples. So as we're starting to multiply, you have to start multiplying i's, right? So we know that I is the square root of negative 1, and that's great. We can use it when we see a negative under a square root. But what happens if I have to multiply I times I? That's going to give me I squared. Anytime you see I squared, technically it's the square root of negative 1 times the square root of negative 1. The answer is always going to be negative 1. So anytime that you see I squared or you're multiplying I times I, it comes out to negative 1. That's something you do want to kind of burn into your brain because that pops up a lot. So what happens if I have I times I times I, which is I to the third? We know that. So just think about it. I squared is negative 1. And then when we're taking negative 1 times I, that would give us negative I. Okay. So once again, I is just kind of its own thing. I squared is negative 1. I to the third is negative I. And then we also need to know I to the fourth. And then we'll talk later about what happens if it's over that. But just think about it. I squared is negative 1. I squared is negative 1. If I multiply those two things together, that's just 1. Okay. So that's something you definitely want written down for now. You'll get used to it that you'll know those because they pop up a lot. But whenever you see I squared, we're going to replace it with -1. Whenever we see I to the third, we're going to replace it with -I, and I to the fourth gets replaced with 1. Okay, so let's just do a few quick examples where that stuff pops up. And then we'll go from there. So we have, I'm just going to do them over here. I don't like to waste paper. So just some examples. Boop. If I said, hey, what's 4I times 6I? You would say, I can do that, right? I'm just multiplying two things. We know 4 times 6 is 24, but then once again, I times I is I squared. So when you give a final answer, you don't want I squared in your answer. Anytime you see I squared, you replace it with -1. So this is really saying 24 times -1, which is -24. So that would be your final answer there. So just as a heads up. So it's just one of those things that kind of pops up you need to pay attention to. I squared. All right, let's look at another example. How exciting. Let's say we had 5 square root of -2 times the square root of -6. Okay. I have to take care of some things, right? Because so here's what you can't do, because I feel like you want to do this. I feel like this, just, you want to just start multiplying, and you want to say that -2 times -6 is +12. Unfortunately, you can't do that. You have to take care of the negatives before you multiply. So I'm going to rewrite this as 5I square root of 2 times I square root of 6, because neither of those can be broken down, but I can take the i's out because there's negatives. Now I'm going to multiply. 5I times I is 5I squared. Under my radicals, 2 times 6 is 12. All right, so now we're saying, well, what the heck do I do here? Well, let's break down square root of 12. So a lot of things you can kind of do in a different order, and that's okay. I like to kind of deal with my radical once everything's combined. So that would be 4 times 3, which would be 2 square root of 3. But remember, we still have, just like don't lose things. That's what always tends to happen here. Okay, so that gives us that. So that would be 10I squared, square root of 3. But anytime we see an I squared, we replace it with -1. So 10 times -1 would be -10 square root of 3. What a beauty. So once again, like, you've done radical stuff before. This isn't new. Maybe it's a little rusty. I'll give you that much. So it may have been a while since you've done it. But I know you guys did quadratic formula last year. You did all that stuff where you were breaking down radicals. With your little heart's desire there. But we just need to make sure, if nothing else, we're staying organized. So you need to take care of your i's first. If you see those negatives, that's your first step. Once those i's are out, you can start combining. So we're multiplying to just combine things together. Once things are combined, I need to break down my radical. And then once I break down my radical, I can just simplify as much as possible. So just steps to get used to. Remember, this is day 1 and you're watching a video. So we will do plenty in person as well. It's more just as a intro for you. I didn't want you to be too bored without me. All right, let's try one more example. So I put this in just so you see the setup and you can kind of remind yourself of a few things. Whenever you're squaring something, you're multiplying it by itself. So when I see this squared, I'm just going to take 2 square root of -3 and then multiply it by 2 square root of -3. So just as a reminder, when you see something squared. So I just start to think, don't multiply it. I feel like that's what I want to do that. No, take care of those negatives first. 2I squared of 3 times 2I squared of 3. Now I can multiply. Gives me 4I squared square root of 9. Hey guys, I know the square root of 9. It's 3. So that's 4I squared times 3, which is 12I squared, which gives me a final answer of -12. What a beaut. Okay. So I have one more type of problem, just one more multiplication example. And then I'll leave a few for you to try. We'll go over them quick, and then that will be that. So let's do this. Sorry, I'm like all sorts of weird on my paper here today. All right, we have this problem. We've done this problem a million times. We've distributed in every chapter, I think, so far this year. So we're going to distribute. Just to keep in mind, stay organized with those i's. So when I distribute, I get 8 minus 2i plus 24i minus 6i squared. Okay, that wasn't bad because we've done that step a million times. So here's what I do. You can either rewrite it or just kind of organize yourself, but I deal with that I squared next. So just as a reminder, this is really saying minus 6 times negative 1. That turns to a plus 6. So I take care of that first. When I see an I squared, I replace it with negative 1. In that case, I had 2 negatives, so it did turn positive. And now I'm just going to combine like terms, going back to adding and subtracting from what we went over at the beginning. 8 plus 6 is 14. And then when I combine those, I get plus 22i. You can leave it like that. I know some people like to say like, oh, there's a GCF. I'm with you. Like, I don't like when things have GCFs. So you can also write it as 2 times 7 plus 11i. I don't really care which way you write it. I'll probably just write it that way to tell you the truth. But once again, we call this a complex number. There's a real part, 14, just a regular number. And then there's an imaginary part with the I. And you can only combine like terms. So the real and imaginary do have to stay separate. Okay, so let me give you just 2 examples just to see how you're feeling. You are going to try some problems in that problem set. So I will be posting that, I need a new piece of paper, on Google Classroom. And then just remind yourself, do your best because we're going to have plenty of time to go over this in person as well. So sorry, I can't be there today. Trust me, I'd rather be there. So let's try 2 problems. Pretty sure you may have just heard my stomach rumbling. I'm very hungry right now. Okay, there's 1. And then 2. Ooh, let's do a fancy one. Let's see if you can remember how to do this. And if you don't remember, you know you can just wait a minute and I will do it out for you in a second. So I'm just going to wait like 10, 15 seconds. You can pause it. And then once you turn it back on, I'll go over them. All right, so I'm going to start going over them. Feel free to pause for more time. You probably need it because that was only like 10 seconds. So what I'm going to start doing is just like, organizing myself. Main goal is take care of those negative radicals first. So this would be I square root of 10. I can't break down square root of 10, so I'm good. Times 3i square root of 2. So I took care of the negatives. Now I can multiply them. I times 3i would give me 3i squared. Underneath my radical, 10 times 2 gives me 20. You can do things in different steps. It doesn't really matter. I'm going to break this down because it is divisible by a perfect square. That would give me 2 root 5 times 3i squared. And then just remember, I squared turns into negative 1. So that's actually negative 3 times 2 square root of 5. And my final answer would be negative 6 square root of 5. Obviously, you can probably do the step in your head where you're just changing that to a negative. But I like to write everything down just so you can follow along. But that would be your final answer to number 1. So see if you could get that. If your steps were in a little different order, that's okay. You don't necessarily have to go in one specific order. The main goal is replace those negatives with i's as your first step. Number 2, let's see if you can remember how to do this. I kind of mentioned it before, just as a hint. We have something squared. Please do not just start squaring everything. No. What that means is you take this and you multiply it by itself. Booyah. Then we distribute. 4 plus 6i square root of 2, right? Because 2 times 3 gives me the 6, and then the other stuff just kind of chills there. And then that would be plus 6i square root of 2. And then just be careful on this last bit. 3 times 3 is 9. Sorry, I forgot what sign I was doing. 9. I times I is I squared. Square root of 2 times square root of 2 is the square root of 4. I can simplify that in my head. That's actually going to be 2. So I'm just like organize them first. So we end up with 4. I can combine these right away. 6i squared root of 2 plus 6i squared root of 2 gives me plus 12i squared root of 2, right? Because I'm just adding 6 plus 6. Here, this turns to a -1. 9 times -1 times 2 is minus 18. And last but not least, I'm going to, is that a minus or? Sorry. I'd done this on a piece of paper. I'm pretty sure I did it wrong because that's 9i squared 2. It was a positive, so then that would turn negative. Yeah, you crazy lady. I wrote it down the wrong way. Once again, a reason not to rush. 4 minus 18 gives me negative 14 plus 12i root 2. You can also, if you wanted to take the GCF out, go for it because those are both divisible by 2. And that would give me -7 plus 6i root 2. Also a perfectly fine answer. But once again, you have a real part, you have an imaginary part. They kind of stay separate because that's the way a complex number is. So, my friends, that is today's lesson. So you are going to be trying numbers 1 through 30 in that problem set. I will post it on Google Classroom. You can just do them right in your notebook. So there's nothing too fancy or special about them. They're just problems. So I'm sorry if I didn't get you the handout, the copy version. I'm a bit of a mess lately. But that's the deal. So have some notes, hopefully. Try those problems. I will hopefully be seeing you soon. And we will continue and ask and answer questions and all that fun stuff. So feel free to write questions down, circle stuff. Just do your best, and we'll continue from there. Have a good day.